All right, Yuri, we're back. Yes, Yuri's he's acting very upset. I think he does not like being out of school. I mean, who does? Can't figure out what he's going to eat or drink or anything. I never thought about what he does to stay fed and hydrated. But Yuri, it's okay. A lot of it, I've got 1, 2, 3, there's 4 for today, and I don't have sticky notes at home, so they can't stick to Yuri. He has a hard time holding them up for me. So we'll get through them all, Yuri. It's okay. Wind and water, well sorted. Unsorted, glaciers and gravity, my absolute favorite website. Don't try to go to it. It's not a real website. So this is the way to kind of keep all of these facts and agents of erosion. The agent, if I have any sound effect skills, there's going to be something playing right now that, it's a little spy video for the agents of erosion. These 4 things, and figuring out, do they leave well-sorted or unsorted deposits? So well-sorted, that was when the deposits are kind of similar shape, usually rounded, but they're sorted and there's a pattern, okay? So we're going to go through those patterns over the next 4 videos, and then unsorted deposits from gravity and glaciers, those will be in the future videos, okay? For rivers, I think this is the order I wanted to go in. Some of the river features we're going to look at. Deltas are a big feature, and they leave horizontal sorting, okay? The term comes up the mouth of the river, which sometimes is confusing for people. That's where the river flows into the sea, or a lake, or something like that. So different river features. A delta is the number 1. There's a bunch, but delta is the number 1 feature. A couple other things with rivers that we're going to talk about. Maybe I'll split this up into sections. I'm not sure. Rivers, old rivers versus young rivers. So old rivers are near the mouth of the river. They're where the ocean is getting close. The river's older because it's been flowing for longer. Usually it's flatter near the coast. Usually there's those meanders. Meanders are when rivers kind of do those turns, and they have a lot of volume. Young rivers are in the mountains. That's when the rivers are the fastest. They're the steepest. They have the highest gradient. They flow the straightest because they're going straight down the mountain. They make a lot of whitewater. So if you're going to go whitewater rafting, you would go in the mountains to do that. Every river you see makes a V-shaped valley. That's a huge important one. I just forgot my trick for that. Let's write that down right now. See if you could remember what that trick is. Did you remember? If you write the word river, the middle letter of river, the same thing's going to happen with glacier when we get to glaciers in a couple of videos. The middle letter of river helps you remember what shape the valley is. And then the 4th thing, I think that's all the papers I have in front of me here. Factors that affect stream erosion or stream velocity. Faster stream, more erosion. When the volume goes up, so these are relationships. As the river volume goes up, the erosion goes up. Volume is the amount of water. More water, faster river. That makes sense. The springtime, the streams have more water because all the snow is melting. That shows up on the test, a decent amount. Gradient. So when the gradient is higher, the erosion's more, the velocity's more. Steeper streams flow faster. A lot of this stuff's common sense. It's just the vocab terms. And then stream channel. This one's a little more confusing. If the stream channel goes up, your erosion's actually going to decrease. So my fantastic art skills here. Let me try to color that in while I explain. The channel is always, it's going to be a U-shaped channel, even though the valley is V, okay? If that channel is wider versus narrow, if you narrow up a stream, like if it goes through some hard rocks in the mountains or something and gets funneled in, if you funnel in a stream, if the stream gets more narrow, it's actually going to flow faster. So if the stream channel gets wider, it's actually going to flow slower and you'd have less erosion, okay? So I'm going to probably cut back and forth to some questions. Maybe you already answered the questions. I'm not sure how I'm going to make this video work. Yuri's here, and I got nothing else. I'm running out of funny stuff to say at home. I must be funnier at school. I'm not sure. All right, me and Yuri are here, even though you can't see us. We're going to explain a couple of diagrams and go through some review questions for you. So this stream right here, it doesn't really matter which way it's flowing, but say it's flowing this way, okay? Where's the stream going to erode and where's it going to deposit the most? Okay, streams are going to flow the fastest where the most water is. So just like when you're going in a car around a bend, on the outside of the curve is going to be the fastest flow. Okay, then it goes back to the middle here, and then if I could draw straighter, that would not have bumped out like that. And so the stream maximum speed, maximum velocity is going to be along that path. And if you see, the outside curves are faster, so there's more erosion over here. Okay, it's really hard to write with a computer mouse. And more deposition is over here. So outside is erosion, inside is deposition, and right in the middle on a straight section is where the water flows the fastest. And if I get real fancy here and I switch to, can I switch to a, look at that, crayon, a red crayon, the fastest flowing water is going to be just under the surface in the center of the stream on a straight section. It would be on the outside on a curved section. Okay, same kind of thing here. If we look at our stream here, more erosion here, so it's deeper and it's not as deep at B. So A is the deeper, and then C is that fan-shaped deposit. That's the delta. My handwriting's messy enough. Let's see if I can write with a crayon. So that's your delta. Now I want you to try to think as I'm writing this word delta. What would the stream channel look like from A to B? That side view, that channel profile? Try to draw it in your brain. Okay, I'm going to draw it over here to the side. If this is the top of the stream and this is A, okay, wow, really bad writer. And this is B. Okay, that stream channel, it's going to be deeper at A and not as deep at B. So it's going to look something like this. It's going to be deeper towards A. Oh, look at that. My art skills came back. Okay, and so that's the side view of the stream. And if you had to pick where is it flowing the fastest here, I would pick right about there. That spot there. Just under the surface, over the deepest part of the river. Okay, let's get to a couple review questions. I've got my crayon out here. I have to think through these relationships, okay? Discharge is how much water flow. So when discharge goes up, what's going to happen to the velocity? So I think in my brain, I'll use the first one that they give me. If the discharge is low, if the volume's low, what's going to happen to the velocity? Low volume, slower. More volume is going to be faster. So if I make those two dots and then I connect them, that's what my line should look like. These aren't perfect matches, but choice C would be the best match for that. They love these graphs. It's basically the same question from a different year, but they drew the graphs slightly different. But it's the same thing. Stream discharge, they're calling it now. When the stream discharge is higher, velocity is higher. Just the exact same thing we did. So it would be choice C. Happen to be the same one again. When we look here, this is the side view. Okay, so you've got this side view, and it's a tricky way to ask this kind of thing. So try to pick out which one you think it would be. Okay, walk through A, B, C. Where's the water going to be flowing the fastest and the slowest? And I'm basically going to know what go with the one thing that I know. C is the fastest. If C is the fastest, this one here makes the most sense to me, that that's the highest. You know what I mean? And this happens to be the only choice, with C being the highest velocity. But as you get closer to the edge, the water flows slower because it's not as deep, and there's more friction with the bottom of the surface. And this other question here, if I go to my crayon, I'm going to go back to blue, because water in blue. Okay, this is a bit of a curve. So if you're trying to think in your head, which one would you pick? Okay, X is the outside of the curve. So you should be trying to pick one in your head right now. I'm pausing. I'm slow talking here, so you can pick which of these would I go with. If X is the outside, this is the fastest water. So the fastest water would be there. This would be the deepest. This would make sense. This would be a straight section. So from X to Y for choice A,
that would be more like right here, which you can see in the diagram. And B would be the outside of a opposite type curve.
Yuri with his notes. What'd I do this time, Yuri? That's not very polite. Old man. Not that old. Old man. What happens to that? Yuri, I don't know about these art skills here, man. What happens to that in a river? Oh, it's a bit. What happens? I did forget that. What happens to a big rock in a river? Well, as a rock stays in a stream, what's going to happen over time? Two things. It's going to get smaller and it will be more rounded. So river deposits are going to be very rounded and they're going to shrink over time. Okay, also, you didn't even remember this one, Yuri. Okay. So the main word, don't forget about Amos, the amazing science machine, the rock tumbler, abrasion. So abrasion, the things that is the process that makes all of this shrinking sediment happen. As those stream particles are bumping into each other, they shrink because of abrasion. Okay, huge vocab word. And transported sediment. Streams transport sediment. So if you take a bunch of bedrock in one area and you put stream deposits on top of it, they're not going to match up. They're going to be made of different things. So transported sediment, the dirt from a stream does not match the bedrock underneath it.
Okay, I just wanted to, Yuri really wanted to, and I agree with him, go over a few things that I kind of didn't cover good enough in the video. A watershed. So we drew this picture earlier in the year. A watershed is just an area that entirely drains into one stream system. So that's a continental divide, and then this is the watershed. All of this area here drains into the same stream that runs there. That word shows up sometimes. Tributary. Ooh, wow, bad circling skills. Tributaries are the smaller streams that flow into bigger streams. So that was like the Mohawk River flows into the Hudson River. The Mohawk's a tributary of the Hudson. Potholes, okay? So potholes are a stream feature. When you have these rocks here, and as usually they're like from flooding events, say when glaciers melted very fast or something, they would make a lot of streams, and all of these rocks would bury their way through abrasion and dig these big holes out, and you'd have these smaller, really round pebbles at the bottom. Meanders, we kind of mentioned, but we didn't talk about the Oxbow Lake. So this stream used to flow through here, but then eventually the stream will try to take a straighter path towards the ocean, and when it goes through and it cuts it off, that lake left behind is an Oxbow Lake. We also didn't, I didn't do the best job ever of showing how waterfalls, as they go over, we talked a lot about how the hard rock, like the Niagara Falls with Niagara Escarpment, the hard rock kind of sticks out and the soft rock is really what gets eroded away. The hard rock is more resistant to erosion and the softer rock erodes faster, but eventually this breaks off and you get these big boulders at the bottom of a waterfall that will start to break down. Then if we look here, river deposition feature, I showed you this, that horizontal sorting, so don't forget about these diagrams here. That's the side view of a delta, we drew that. An alluvial fan was one that I forgot to mention. When rivers come out of the fast mountains, the steep mountains, they will slow down, and since they slow down, the biggest particles can't get carried by that water anymore. So you get another horizontal sorting event, which is called an alluvial fan. Very, very similar to a delta. The only difference is it happens on land instead of in the water. Okay, I just wanted to, Yuri really wanted to, and I agree with him, go over a few things that I kind of didn't cover good enough in the video. A watershed. So we drew this picture earlier in the year. A watershed is just an area that entirely drains into one stream system. So that's a continental divide, and then this is the watershed. All of this area here drains into the same stream that runs there. That word shows up sometimes. Tributary. Ooh, wow, bad circling skills. Tributaries are the smaller streams that flow into bigger streams. So that was like the Mohawk River flows into the Hudson River. The Mohawk's a tributary of the Hudson. Potholes, okay? So potholes are a stream feature. When you have these rocks here, and as usually they're like from flooding events, say when glaciers melted very fast or something, they would make a lot of streams, and all of these rocks would bury their way through abrasion and dig these big holes out, and you'd have these smaller, really round pebbles at the bottom. Meanders, we kind of mentioned, but we didn't talk about the Oxbow Lake. So this stream used to flow through here, but then eventually the stream will try to take a straighter path towards the ocean, and when it goes through and it cuts it off, that lake left behind is an Oxbow Lake. We also I didn't do the best job ever of showing how waterfalls, as they go over, we talked a lot about how the hard rock, like the Niagara Falls with Niagara Escarpment, the hard rock kind of sticks out, and the soft rock is really what gets eroded away. The hard rock is more resistant to erosion, and the softer rock erodes faster, but eventually this breaks off and you get these big boulders at the bottom of a waterfall that will start to break down. Then if we look here, river deposition feature, I showed you this, that horizontal sorting, so don't forget about these diagrams here. That's the side view of a delta, we drew that. An alluvial fan was one that I forgot to mention. When rivers come out of the fast mountains, the steep mountains, they will slow down, and since they slow down, the biggest particles can't get carried by that water anymore. So you get another horizontal sorting event, which is called an alluvial fan. Very, very similar to a delta. The only difference is it happens on land instead of in the water. And the floodplain. So I really didn't cover nearly as much as I wanted to. So I had to add this in before we sent out the video. The floodplain is a really flat area on the sides of a river, and when it floods, it gets filled up with a lot of silt and clay, and then once the floods recede, all of this right here is very silt or nutrient rich. So these particles here are very fine grained on the side of a river, and they're really flat, and there's usually two taller areas on each side called levees that kind of make the boundaries of those floodplains. So I think that did that show up in the picture down here? That's a side view of that same floodplain right there. You can see those smaller deposits. So I forgot quite a bit. My fault, not Yuri's. And that should wrap up your river and stream erosion and deposition. Agent number 1 is done. Couldn't figure out